So, good evening, guys, and welcome to the second session of Android Study Jams. I am Kirtana, the community lead of Google DSC NIT Trichy chapter for this term. And today we have Amin with us who will be facilitating this session. So, over to you, Amin.
Hello everyone. I am Amin and welcome to the second session. Am I audible?
Yeah, you're audible.
This is the second session. We will be learning more into Kotlin. We have from where we have left off. We will be continuing with the topics, and this will help us in being more comfortable with the language and help us when we are starting to develop the app. We are hoping to start it by next session, which will be on Thursday. Yeah. So in this class, we'll be learning about conditionals and control flow, and we'll be looking into loops, arrays, and lists, and object-oriented programming concepts. So Kotlin is like object-oriented language. So we will be looking into those concepts and classes and objects. So yeah, let's get started. So conditionals, it basically allows us to handle decision making. So if we have based on a condition, if we want to execute a certain code, then we will be using condition statements. So we have two types. One is if-else statements. Many will be familiar with this. This is basic if condition. Then we have when statements, which is kind of new and Kotlin. So we'll be looking into that. So if statements. So we have this is the basic syntax. So if we can compare two values, so we have number of cups and number of plates, and here I've written like an example code where we, depending on the condition, so if number of cups is greater or number of plates is greater, we have different outputs. This is the basic syntax. Then we can move on further when we have more conditions. So we have so say we want to say if there are 0 guests, we want to print no guests, and if it's within a certain value, then we want to say like there's a small group of people, and then else like we can say there's a large group of people. So this is basically like the if ladder, so that allows us to do that. And this is another example where we want to look at the condition for the eligibility of work. So if they're between the age of 18 and 60, then they are eligible to work. Otherwise, they are not eligible. And so here you can see I checked if both the condition and use the and operator to ensure that both the conditions are satisfied. And it's a bit like it's for what it does, we can it's a bit clunky code, like we have to check both the condition and then put and. So to remedy that, we have this thing called ranges in Kotlin, which is basically like a span of comparable values. So let's say we have 18 to 60. That's a range of values which are comparable as in like you can check like 16 is less than 17, so you can do a kind of comparison between them. So for that, we use ranges, and ranges are bounded by two values. And here you can see I've used that to make this code. So previously, as you've seen, I used the AND operator and stuff. Here I have shortened it to if age in and 18 dot dot 60. With this dot dot as the range 2 operator. So I've used that to check the condition. And it basically serves as the previous code, but in a more elegant manner. And then we come to the when statements. If you are familiar with C type languages, you can think of this as similar to switch statements, where we have when value we pass in. So I'm passing in results, and it compares it to different conditions. So if the result is 0, it gives no results. And if it's in between a range, so this is it got results, and there's an else condition as well. That is like none of the conditions are satisfied, then this is printed. So this is similar to switch state. You can look at this further examples. Like here I have set up similarly, like all the codes. So we have these conditions here, and then else if run it. Here I've set the guest value as 30, and so it's greater than 20. So this else condition gets satisfied, and it prints this. And so you have large group. Here age is 18. So it says you are eligible to work. Let's say we have 17, then we'll say not eligible to work because the condition is not satisfied. And we can change this to age range also valid. Here you can see 18 is included, so it's inclusive of these both values, 18 and 16. So that will also be eligible. Yeah, and that range operator works for characters as well. So P to Z, that's again, you can compare between letters. So P is less than Q. Since we can do that basic comparison, we can also use that in this syntax. And here we have when statements. By the way, these conditions, you can give any conditions here. If it's say like I can 5, so results will be compared to 5, and if it's 5, then it'll say let's this one as well. It's just it can be any comparison statement, and it will get compared to that, and the corresponding output will be shown. Right. So I hope that's clear. Anyone has any doubts in this? Okay. Okay, we'll move on to loops then. Loops is when you want to basically run a piece of code multiple times. So you loop through it. And there are different types of loop. One is for loop, which is you can use this syntax for I in 1 to 5. This range we are using it again. So I will go from 1 to 5, and we are printing I. So this will be output. And you can use down to, which basically goes from 5 to 1. So instead of dot dot, if you use down, it will go down to 1. And we can use, there's another thing called step. So if you want to make 2 steps at a time, so here I've started from 3 and then took 2 steps and got to 5. And then 6 was the limit, so it stopped there. And we can do the same for characters as well. And another type of loop is while loops, which is where we have the syntax as the word while, and then we give a condition, and the code inside this curly brackets will keep running until this condition is no longer satisfied. So here I have started with bicycles as 0, and then I've incremented it to 50. So here I'll give the output as bicycles, 50 bicycles in the bicycle. And the next type of is do while loop. It's similar to while loop, but the condition is checked in the end. So while the code is exiting from this loop, it checks the condition and then decides if it has to run it again or not. And then we have repeat. So this is if you want to repeat a certain piece of code, like certain types, you can just write repeat 2, and then this will repeat the code inside this 2 times. And, you can see this here. As I've explained, all of this here. One thing to note here, do while loop, I've incremented bicycles, right, this value to 50, and I'm checking bicycles is greater than or equal to 50. If this was a while loop, it wouldn't run because this condition is not satisfied. But then since I did the do while loop, it gets run once and then we check. So yeah, that's the, any doubts? Okay, right. We'll go to lists and arrays. It's when you want to store like variables in a certain range, or if you want to store a group of variables, you use lists. So they are ordered collection of elements. They're different elements and they have a certain ordering to them. It's lists. And in Kotlin lists, they are immutable, as in you cannot change or add stuff once you have declared them. So the lists are immutable. Uh, so you can use this syntax val instruments equals list of, and then see I have a list of string variables. So these are the names of different instruments, and I have put them into this instruments val. So this is basically a list. If I print it, I'll get a list of instruments. And if you want to have a mutable list where you can remove and add elements and make changes to the elements, then you would have to use mutable list of the syntax to have a list which you can mutate or yeah, change. And here we have seen like val usually means it's a constant, but here you can the val is a constant with respect to the name mylist. So you can't have this list point to a different list because it's val or constant. If you had var, then you will be able to make this variable point to different lists as well. So that's how the val part works. And the list part is separate from that because it's a mutable list. And then we have arrays. Arrays are similar to lists, but then they have a fixed size and they are also mutable. And they can store multiple items. And we can see here an example of array. Val pets is equal to array of, and then we have different elements to this pets array. And here I'm printing the arrays as strings. So I'm using a utility function in Java to print it in one line. There are other ways to print strings and arrays. You can loop through an array and print each element or something similar. So that's array, and you can have mixed data types in an array. So that's also possible in Kotlin. You can have array of hats 2 here. Hats is string data type and 2 is integer data type. Both are part of the array. And you can have basically arrays of one type as well. So if you do int array of, then you can have integer arrays. The basic array of will have can have different types. And so we have the option to combine different arrays using plus operator. So we have two int arrays that I've made, and then we can use the plus operator to combine both the arrays and store it in a different variable, which gives us the combined array. So here numbers 2 I'm putting in the beginning. So 4, 5, 6 is part of numbers 2. It will come in the beginning. Then I'm adding numbers to it. Numbers will have 1, 2, 3, and that will go to the end of this list. So the combined list will have 4, 5, 6, 1, 2, 3. And as I said before, right, we can traverse through arrays and print them using loops. So here I created an array of pets and then using for loop. So here for loop, I'm using element as the looping variable. So element will get the values of all the different data types in this array. And so the array is pets. So element will first get the value dog, and then it will have the value cat, and then we'll have the cat value canary. So when I print them with plus operator, it will keep printing them out, and I'll get all the elements of the list printed out. So yeah, we can see this example for this. Right. So here I have shown the how we can combine two lists. So I've taken two lists of instruments and combined them. And we have just instruments. If we print, it's trumpet, piano, and violin. If I print like combined list, it will have both the lists printed as like one. So if I do this first, then I'll have the second list printed out first and then the first list. So guitar, flute, and trumpet is first, and then we have the instruments in the instruments variable. And now we have here we have a mutable list. So this, if I use list of, it's not mutable. So if I try to, let's say, do like certain element like instruments of the list starts from 0, and so each element, this will be 0th element, first element, second element. If I try to will not allow me to do that because it's not mutable. So if I want to do that, then I'll have to have a mutable list. So this is, and here I can remove elements and add elements, etc. And you can see it here: trumpet, piano, violin, and then I've removed violin, and then I've added guitar. So yeah. And yeah, so we have different ways to print, like let's say you want to print the pets array. So we have different ways to do that. One was through looping, and the other is you can use like functions which are already inbuilt. So if you do print pets.join to string with space, it will join all the elements into a string with space in between. So that's what we are seeing here: dog, cat, canary. And yeah, and you can also use a utility function which will allow you to convert it into string automatically, and that's also there. So that will give this output. That's also a way to do it. And then we have different data types here, which also you can see. And here I'm printing each element. So mix is the array, and the 0th element is hat, and the first element is mix 2. So mix of 0 and mix of 1 will give hats and 2. And so I've shown how to combine different arrays and output it. So that combined array you can see here, and array traversal as well into specific syntax. Any doubts? Okay, I hope it's clear. Now we'll be moving on to functions. Functions is a block of code that performs a specific task. So I like to think of it as a machine where you give a certain input and it gives back a certain output and does some processing to it. And so that's kind of what like function does, and it helps to make a large program into like different pieces so we can arrange it in a while, make easier for us to program and think about what different stuff means and how it interacts with each other. So a function can have different arguments and can be either named arguments, and we can have certain default values to each of the arguments. and so on. So we can look further into it. We can have, this is basically how you declare a function. So print hello, the fund keyword is used, and then we have a block of code hello, and print hello, and then this function gets called and all the contents of this file gets, this function gets executed. And one unique thing, like in Kotlin, we have to note usually in C other languages we use void when we don't have anything to return for a function. So we, let's say we want to just print, so we don't return anything. We can use this thing. It's called unit. That's basically like something you return when you don't have like anything much to return to. So Uh, also, like we can see unit is not compulsory. It's by default. The compiler knows, like if you don't specify any return types, it is usually like considered as there's no return type, or unit is a return type. And we have functions. We have three things. It can have default parameters, required parameters, and named arguments. So default values you can give to stuff where like by default it's a certain value, and then if you want to change it, you can pass the value and it will override the default value. So here, if you call drive, the default value for speed is the argument, is fast. So speed by default is considered fast, but if you pass in slow, that means it will override that and speed will get the value slow. And you can, in Kotlin, you can give the arguments with their names as well. So if you want to if you have multiple arguments and you want to clarify which you're giving, then you can write speed equals dirt, like so. Speed gets the value dirt. Right. And so required parameters, when you don't have a default value, you will have to pass that value. Otherwise, the that compiler can't know what value it has. So if it has a default value, then you don't have to pass it. It'll consider the default value. But if you don't have a default value, then that become a required parameters. And to make the function call, you will have to pass that required parameter. And yeah, so default versus required parameters, just what it is. And we have named arguments. It's to improve readability. So if you have like a lot of arguments and you want to like specify or to read, when you're like reading it, it'll be more clear what you're passing in each thing. So that's why you can give specifically put the name of the variable you're passing. And so here we have like another convenience kind of thing where we can have functions shortened out. So here is a function double which returns a value int. So this is how you put a colon and put int. That means the function is going to return int, and you put this block and you put x into curly brackets. And you can have a compact version where you can just put the equal to sign and then it'll just compute it. Works the same way and it's easier to read. Here I have defined a function like find area. So it will take in an integer which has a default value 7. If I don't give anything, 154, which is it takes the default value as 7, so the area is 154. If I give 8, then we'll give a different area, 201, which is so the radius becomes 8 instead of 7. And here we can see like here I'm just printing, so print hello, calling this function, print hello. Here, since I'm not passing any default value to this string, it's asking me like I'm not passing anything, so it's causing issues. So here I will have to give some default value. Then if I don't pass also, it's fine. So here unit, that's the, since I'm not returning anything, I can give it as unit. And if I add that, so since any doubts? Okay, I hope it's clear.
Can we have multiple arguments for the function?
Yes, we can have multiple arguments to functions. I show it. So if you want, let's say, L, so that and then, see here, I found the area using length and breadth. So here L is the first parameter, that is 3, and breadth will be 2, and then I'm returning L into B. So when I'm printing it, it becomes 6. Here, as I said before, we can name the parameters. So I can give L equal to 3 and B equal to 2. So that will also work. Here I'm explicitly mentioning length is 3 and breadth is 2. Is that clear? It works.
Yeah. Okay.
So next we'll be going into object-oriented programming. It's a programming paradigm that is based on objects. So if you look at the real world, we can see like various things, like let's say your phone or your watch. It's an object and it serves a definite function, and it has some attributes to it. So let's say like my watch, it's brown color, and it is a digital watch, so that's one of its attributes, and then it has a function of showing time. So all of that are related. So the watch is an object, it has some attributes and some related functions. So to model that kind of objects, we have the object-oriented programming. It's a and Kotlin also follows is under like object-oriented programming language. So, it mainly achieves this through a thing called class. So we have different objects, and to describe each objects, we have a class. So we can say like there is a class for a house, and so that will be like the planning or like the blueprint of the house. And from that blueprint, we can build different houses like of varying colors and varying properties. So that's what classes are in general. Yeah, it'll have like different methods, and different methods. It's similar to, we say methods when an object has like specific functions, they're called methods, and they have like attributes to it. We have what's a difference between a class and an object. So uh, as we said before, like a class is the blueprint of the object, and the object is can be thought of as an instance of a class. So we have the class describing about the properties of the house, and the house itself will take on those properties. So uh, yeah, that's how classes and objects are. And we'll be looking further into it. So we have a constructor. Like if you're going with the house example, like let's say you have a blueprint and you want to make a house. So you would have like, you would describe its properties, like I want a blue color house. I want like certain windows and doors in this aspect. You would describe the house, and then the constructors, they will like be able to make that happen. So that's what we're doing. We have parameters which describe like the properties of like the different attributes, and then we have uh, different ways we can do it. So there's like this is how you would like make class. So you would say class A, then this A is a class. Uh, and similar to a function, you can pass in some attributes, parameters, which would come into the constructor of the class. So here we have defined a class A, and then we can have different variables. These are objects. So AA is a variable like val, which has the properties of class A. So we are assigning class A to this value. And we have class B similarly, like we can pass in int as a parameter, passing it as a parameter. And here it's pointing out that X is just to be used within the constructor. It is not actually a property of B. And so we can't access like X as a property from the object. And for the value, if we give, instead of just X int, if we give it as a value, then we'll be able to reference it from outside the constructor, and it will be instantiated for all the objects of the class. So we have default parameters, like similar to how we saw default parameters in functions. So we have similar way, we have parameters to these constructors which build the object. So we have class box, and it has different value properties. So box has a length, it has a width, it has a height. And for width and height, we see that we are giving a default value 20 and 40. And so when we are making an object, we are assigning this class to this object. So box1 equals box. And I can pass in all the three parameters. So it will override whatever we default parameter we get, or I can just give the ones which are already don't have a default value. So length doesn't have a default value. I can just give length and specify that. And now we have different types of constructors. The primary constructor, which is the default one, like the one which receives these parameters. That's the primary constructor, and it goes inside the init block. And so this is like similar to if we use the word constructor keyword and then pass the parameters to the constructor. It's the same as if we have the parameters within the in the class itself and then use a body as in it. So these are just different syntax for the same constructor. You have the initializer block, which is what code which is inside the init that is run inside the init block. So you can have multiple init blocks, and init block is basically like the body of the constructor. And so here we have an example of class square, and when we make an object using this class, what happens is init runs, this block of code runs, and it prints like side into two. So when we make the class, an object from this class, like let's say S, it's an object of class square. And so it takes the parameter 10 as the side, and it displays side into two, which is 20. And here we can have multiple constructors also, and these are called the secondary constructors. And these constructors must call the primary constructor. And or they should call another secondary constructor which calls the primary constructor. And I'll be showing the examples, so if it's clear. If it's not clear, I'll be clearing it then. And so we have this class circle which has multiple constructors. So the primary constructor which gets the radius is this init block. So this will initialize. So it's short for initialize. So this will be the primary constructor, and we have different constructors also. So this is basically if we want to give different types of parameters, then we would use different constructors. So I want to make a circle C which takes in radius, then we would use the init constructor. If you want to give diameter, there's a constructor for that. So that will give like, which will divide the diameter by 2 and get the radius. That's a way to do that. The classes, they will have different properties, which will be like, which can be like variables, so val or var, and we can use the access the properties using the dot operator. So if we have an object named bb and then dot and then the name of the property, if we do that, then we can access those properties. And so here is an example of a person class. It has the name. So if we want to have a person named Alex, we would do val person equals person class and pass in the name as Alex. So this person will get the name Alex. And if you print that using dot operator, so this is the object and this object dot name. Name is the property. So we will give person dot name. This will get the name of the person. So we print Alex. And we can change the property with, again, the dot operator and set it to like different. And we can have, as I said, member functions, which are also called methods, right? So these are like, if we are using the analogy in real world, we would say like different objects, they have their own functions. So like a calculator, it can calculate. So that's what this member function does. So all the stuff that an object can do will be defined in the member functions. And it's like usual function, you declare it using the fund keyword. It will have the same parameters, default parameters and everything. And specific return type. And if it's not anything, if it's not returning anything, it's like void or unit in Kotlin. So we'll be looking at examples of this. Right, here we have like, yeah, different yeah. So we have different classes, class A, class B, class C, class D. So this class has a parameter to its constructor. This, if we put val, this becomes a property of the class. And here it's just a parameter you're passing to the constructor. So that's the difference if you put val or var, or if you don't put anything, that's what happens. And if you have a class, let's say I circle C, it has the property of area. So circle can have property of area, and a constructor, what it does is it takes in radius and it computes the area of the circle and puts it in this property. And we have another class where we can demonstrate init. So if we so these are the two ways of doing the same thing. So here I'm using constructor like keyword. Instead of that, I can use init keyword and have the parameters displayed here. So they basically perform the same way. And here we have another class for circle where we have multiple constructors. Here it's saying like it's never used because I haven't done anything with them. I just initialized them. So it's saying like I haven't used it anywhere. And yeah. So here CC, I'm passing 42. So the class CC is like an object of class C. And this class is here. And it has a property called Y, which is an integer value. So when I pass that and when I print cc.y, I get that value as 42. And I have an object of another class, circle C, which is here, right? And I'm passing the radius as 7. So, and I'm getting the circumference. Okay. It should be circumference. Yeah, so this is calculating circles. Yeah, I wrote circumference, but then I calculated area. Like, okay, IR if you give, we'll get the circumference. So, like, 0.8. Yeah, so here we have like this value and circle 3. This is a different class, circle 3, and it has radius doubled. And what it does, this thing calculates the circumference here. So using the init block, println, so println circumference gives us pi times radius times 2. So this is what happens. This is the line which is getting printed. But when you make an object of class circle 3, then the init constructor gets executed and it prints this line. And here I'm passing in, make it more clear. So I'm having the constructor and I'm making an object of class 3 that is D and assigning 3.5 to it. And so see, since 3.5 is basically a double data type, right? It's a floating like decimal value. So it takes it as the radius because the radius we are defining it as double. So this class has the radius of 3.5 and that radius gets it's basically used in this init constructor and it calculates the circumference as pi times radius times 2. And here if you see, right, we have val e where I'm passing in 7 and 7 is integer type. So what this does is we have here diameter as int. So the constructor considers the 7 as a diameter because it's the integer data type and it divides the diameter by 2 and sets the radius as 3.5. So in the end, both the circumference will be like same because here we are passing diameter, we are passing radius. Is that clear? Okay, we will be going into getters and setters. Right. And this is when you want to get the different properties, you would use getters and setters. So the dot operator, it automatically gets the things for you, and that's been done by automatically by the compiler using getters and setters. So if you want the behavior to be as it is, then you can just use the dot property. But if you want to have custom behavior, then you can define your own getters and setters, and we'll see how we can do that. So here we have a custom getter for a person's full name. So we pass in first name and last name. And if we want to get the full name, then we return the first name and the last name like with a space in between. So full name will be like first name space last name. So if you have a person, we can have the person class as first name is John and then the last name is Doe. So if we print the full name, it will be John Doe. So if we use the dot operator, it uses this custom type of thing where we use the first name and the last name and it prints it out. This is using this syntax, you can customize the get operator. And similarly for the setters, right? If you want to set a person's full name to something, and you can use a custom thing where if you set it this way, like if you write this line of code, what it does is it takes this string as a value, it splits it into two, where the space happens, it splits into two. So Jane and then Smith are like now two things, and puts it into an array. So this component has two names, Jane and Smith, and first name gets the Jane part and last name gets the Smith part, and the field gets the full value. So full name gets the full value. And so that's how you can have a custom way of assigning different variables in a class. See the example here. We have a class person, first name, last name, and I've done take a look how it works. And so here I'm defining person and John Doe. If we print the full name, then we'll get it separated by space. Right. So you can have any custom thing. So if you want in the have an underscore in between, so John underscore Doe, and yeah. So anything you want, like some custom behavior you want to define, you can use that. And then the assigning, same for the assigning part. So if you just assign person dot full name Jane Smith equals Jane Smith, what it does is it not only gives full name, this name, but it also gives here first name will get Jane and last name gets Smith automatically. So it's very, when coding, this setter takes care of all that part. You don't have to manually set like person dot first name equals this, person dot last name equals that. So any doubts? Okay. Yeah. Next topic. It's one of the important topics in object-oriented programming. It's called inheritance. So we have one class and a subclass, which inherits properties from a different class. So as an example, you can think of like an employee. So an employee is like a broad thing. It can be anyone. So anyone in the organization is an employee. But then you can have like different sub divisions in the employee. So let's say an engineer, an accountant, a manager, so on and so forth. So they will have all the properties of an employee. So they're all employees, but then they will have their own like separate functions. So engineer will do what he does, and manager will manage people, so on. And this we can do in Kotlin. And it supports single parent class inheritance, which means you can inherit from a single parent. There are some languages which also allows multiple parent inheritance, but in Kotlin you can do only single parent inheritance, similar to Java. And each class will have exactly one parent class, and that's called the superclass. And the class which is inheriting is called the subclass. And the subclass inherits all the members in the superclass. And we have, as I said, like you can't have multiple parents, so you can't inherit from two different classes. And if you want such a functionality, you would have to have something called an interface. An interface is like not exactly a class, it's something more broader, and it's somewhat different. What it does is it can contain methods, signatures, and property names, and it can derive from other interfaces, and you can derive from multiple interfaces as well. Class, you can only have one parent class, but you can derive from multiple interfaces. And usually you would do something like an interface when you have something like broad, let's say a shape. That shape has like compute area as one of its functions. So if you want, you can like have many shape derived from this. So you can have a square, circle, rectangle, triangle, and all of these have different compute areas, so different formulas for the areas. So that's why this interface is like a thing that connects all of this together and like gives it a certain like structure. So that's an interface. Here we have like compute area that the interface has, and when we are deriving from the interface, so we have a class circle, which we put colon and we put shape. So shape is the name of the class and name of the interface we are inheriting from. And we override so we use the override keyword to override this compute area function. So we override that function to make it specific to circle. So if you are inheriting, let's say a square, then you would override area to make it like formula for square. So right, a square or side square, that formula you would use. And that's about interfaces. Now we can look at extending classes. Extending is also the same thing as inheriting. So we call it extending classes. It means you're inheriting from a superclass. So to do that, you need a new class, which is a subclass which inherits from the previous class, and we have to add some more functionality to the new one. And so in Kotlin, if you want to inherit from class, by default, you can't do it. You will have to have use the open keyword for the superclass. So I'll show it here. So if we declare class A and try to have subclass by putting the colon operator and giving the name A, then it says it cannot be inherited from. But if you use the open keyword, then we can inherit from this class. So we have looked at overriding, which means like if parent class has a separate function for something, let's say a compute area, then if you want the child class to do something different with that function, then you override it in the child. So if you mark it final, then you will not be able to override. And we have a different thing called abstract classes. And this is also a type of class, but you cannot have it instantiated. Instantiated as in you cannot create its objects. So an object is an instance of a class, and for abstract classes, you cannot make objects. Its only purpose is so that other classes can inherit from it. So it's something like, let's say an example like vehicle. So you won't have like, there's no like solid like vehicle thing. It's like either a car or a bus, like some other airplane or a boat. So vehicle is like an abstract concept which collects together and gives certain properties to all of its inheriting like different subclasses. So here another example is food. So food, like it's an abstract thing. It has a calorie, it has a name, and you can like consume it. So I'm creating like a specific type of food. So I'm inheriting from food, but then I'm creating like pizza out of the food. So now I'm defining like, okay, pizza has 600 calories and its name is pizza, and you can consume it, right? And so we'll look at this in a bit more detail. Here we have like an interface for the shape, and we have class circle, which inherits from the shape. And we have an open class C, and from which we are inheriting like T, and the abstract class food, and as explained before. So here we are finding the area as this value. Here I'm creating a new object of class circle in C, and this value gets passed on here, and the area gets computed here. And I'm printing the area as C.compute area. And pizza.consume. So since I'm consuming the pizza, this function gets called, which is part of the abstract class, and it's saying I'm eating, and then name it's pizza. So that name gets printed here. So it says I'm eating. Are we clear? Hope you're clear. Any doubts? Right. And now I'll like, when do we use each of the different things? So when we have a broad spectrum of behavior, we use an interface. So like, as I said, shape, that's like a very broad. So we use an interface for that. And we derive like different shape, like circle, square, and all of that stuff. And if it's very specific, then we use a class. So like pizza is a class because it's very specific. And if you want to inherit multiple stuff and multiple classes, then we'll have to use interface because classes don't allow to have multiple inheritances. And if you want some properties, like let's say instead of shape, you're saying something like a polygon. So, or like a regular polygon. So that is a little more specific and it has certain common, like all the regular polygons have certain properties which are common. So then you will use something like an abstract class, right? And yeah, so you can extend from only one class. Extend is the same as inherit. So in terms of same thing. Yeah. So yeah, that's the end of the session. Any doubts? Gone through these topics? Right. And I've given the links to the pathways which you can like look. So you will have like these are the different pathways. You can go to like introduction to Kotlin and you can take this quiz by now. Like you can, if you have followed the lectures or you can follow through this, you can like take the quiz and see like how much you know about everything. And yeah, that's something you have to go do. And I've given the link to the course as well. And in the next session, we'll be hopefully starting with actual app dev. If you are not very these concepts, I think we went through a lot of concepts today. And if you are not very thorough, it's fine. We'll be learning through as we are making like apps and finding like practical uses for all of this. So that'll be more thorough. Thank you. And tomorrow, like next class, we'll be starting with different like Android Studio. So I recommend you go through this, create your first app, introduction to Android Studio, watch this video, and there's a guide to like download different like Android Studio. So this thing, I'll give the link to this. You can just go through this and you can download Android Studio. So this is the link. So over here, I'll give this link as well. Download Android Studio. This will download for Windows. And if you want to any other thing, you can use download options and you can go for Mac and Linux. If you follow the pathway, like everything is very well documented and mentioned, you can follow through. If you have any doubts, please. Right.
Guys, are there any doubts or questions? All right, I think that's a no, Amin. So yeah, I will be sharing the recording shortly and the PPT by today night if possible. So you can go through the installation guide like Amin said and just get started on the basics. And we will be having the third session this Thursday, that is the 24th of February. And I will be sharing the official event link across all platforms. That will be mail and Discord channel and our Instagram handle shortly. So yeah, that's it, guys. Thank you for all joining.
Thank you.
Yep.
Thanks.
Thank you.